All right, so today we are going to start exploring what ratios are and how we use them. We actually use ratios quite a bit in our everyday life. We just don't necessarily realize it. Whenever we are comparing two quantities, we are looking at using ratios, and they can typically be written three different ways. So we can write them with a colon. So for example, if I was doing a 1-to-3 ratio, it could be written like that. They can also be written as a fraction. So it'd be like 1-to-3 that way. Or the third way is we can use the word 2. So we'd say like 1-to-3. And what we're going to do in our notes today is just kind of explore what these different things mean and how they are used. One thing to keep in mind is that when we're talking about ratios, you always have to remember that order matters. So a 1-to-3 ratio is very different than a 3-to-1 ratio, and we'll kind of look at what that and why that is. So let's look at an example right here. So one type of ratio that we can look at is what's called a part-to-part ratio. A part-to-part ratio is when we are just comparing parts. So what happens is we present one part of a whole to another part of the whole. All right, so I'm going to look at here. So as you can see, I have these different colors of paint, or these different cans of paint. So I'm going to go ahead and color these. I'm going to make these blue. I'm going to go ahead and make these red. All right, so one way we can look at this is that we have three cans of red paint to 2 cans of blue paint. So our ratio would be 3-to-2 of red to blue. Another way we can look at ratios is what's called a part-to-whole ratio. Most of you are going to be more familiar with a part-to-whole ratio because when we look at part-to-whole ratio, that would be more similar to what we would think of when we think of fractions. A part-to-whole ratio is going to provide the relationship between one part and the whole population or the whole group, depending on how you look at it. So for our example, what we're looking at are these cell phones. So as you can see, I have some iPhones and I have some Android phones. So when we look at this, as you can see in our ratio, we're going to be comparing Androids to total phones. So our number of Androids is represented right here. So in this case, there are 3 Android phones. And then because it's a part to whole, we're going to look at our total number of phones. So all of them in the whole group. So in this case, there are 7 total phones. So our ratio would be a 3-to-7 ratio, and that one's a part to whole of Androids to total phones. Now, we can use ratios to help us solve problems and kind of think through. Because a lot of times when we're mixing things, as we found out in that paint mixing activity, we use ratios to kind of make these mixtures and things like that. And sometimes they have to be mixed in a certain way. So we're going to look at this example where Obama is eating 2 jalapenos for every 3 that Amir eats. They're going to eat 20 jalapenos altogether. So we want to know how many did they eat. There are 3 different models that we can use to kind of represent our ratios. So we have a table. We can use what's called a bar or a tape model. And then we can use a number line or double number line. I'm going to start with the table because that one's probably the one that's the most familiar to you. So when I do this, I'm going to look at what's my information that I'm comparing. So I'm really comparing Obama, how much Obama eats to how much Amir eats to the total jalapenos that they eat. So I'm going to label this as Obama, Amir, and total jalapenos. In our original ratio, we see that Obama is eating 2 jalapenos for every 3 that Amir eats. So altogether, when we put those parts together, we see that there are 5 total jalapenos that are eaten. We want to get to a place where we're looking at 20 whole jalapenos that are eaten, or 20 total. So when I think about what am I doing in my table to eventually get me from 5 total jalapenos to 20. And I can either jump all the way there, or I can maybe take some steps depending on how I think about it.
Shocker.
So for one thing I can do is I can think about, like, okay, what if I just double this? What if we just, everybody ate twice as many? So Obama would then become 4, Amir would become 6, and they would get at a total of 20 jalapenos. So here we doubled. And now we can look, we can almost double this again. So then double 6 is 12 and double 4 is 8. And we can double check and say, okay, does 8 plus 6 equal 20? It does. And so in this case, Obama ate 8, Amir ate 12 when they ate 20 jalapenos altogether. So that's a table. One of my personal favorites is actually the bar or the tape model. When I do this one, it's going to be a similar type of setup, but what I'm going to do is I'm going to create a bar or pieces, smaller pieces to represent each group. Once again, I'm comparing Obama to Amir. But this time, instead of writing out the numbers, I'm going to create a box for every jalapeno that Obama eats. So Obama ate 2. So I'm going to cut my box into 2. Amir ate 3. So Amir is going to get a slightly bigger box, cut into 3 pieces. So these boxes now represent that 2 to 3 ratio that was shared in the problem. I want to know how many they'd each have to eat if they're eating 20 jalapenos altogether. So now what I'm looking at is what happens when these boxes have to represent 20 jalapenos. Well, that 20 is now going to be distributed over these 5 boxes. So I'm going to take 20 and divide it by the 5 boxes that we have. And when we do that, we end up with a value of 4. So what that means is that each of these boxes now represents 4.
Chem launcher here. We got you all 3 in sight for the chem launcher.
So now looking at this, we can see that altogether, Obama ate 2 boxes each worth 4, or 8 jalapenos, and Amir ate 3 boxes worth 4 jalapenos each, for a total of 12, which is the same as we got in our table. Our last example is a number line or a double number line. A double number line is really nice because it can show those 3 different values like we did in our table. So once again, I'm going to start by labeling. So I'm going to have Obama, Amir, and then down here is going to be our total. So our original ratio, so this is what's going to be weird about this. On the number line, they're not going to be exactly lined up because I'm going to use the values that I need. Obama ate 2, Amir ate 3, and when that happened, they ate a total of 5 jalapenos. And now, kind of thinking along the same way that we did in the table, we can make these jumps. So for example, I can jump the total to, say, 10 total jalapenos. And in this case, everything is then doubled. And then once again, we could double to get to 20, which would make this 12 for Amir and 8 for Obama. So just different visual ways. They're all kind of doing the same thing, but just different ways to represent our thinking. So you just have to choose the one that makes the most sense to you. The other nice thing is I showed jumps here from 5 to 10 to 20. You could also jump directly from 5 to 20, but I wanted to show you this because sometimes we're going to have to change our numbers around because we might not have a number that goes directly into this next one. So that's just something to think about as we move forward.